Okay, so we've done NAT, DHCP, DNS. Now I need to jump back to IPv6 just to pick up how these things change in version 6, DHCP in particular. So remember, in order to for companies to switch over to IPv6, they have to upgrade all their clients, routers, firewalls, everything has to support the IPv6 protocol, and that can get expensive to retrofit all that hardware, because if it's old enough and there's not a firmware upgrade available, you have to buy a new piece of hardware, and that can get expensive. So right now, most ISPs are running both simultaneously, version 4 and version 6, which is taking up a lot of overhead. Eventually, we want to just turn off IPv4, but within each company's local area network, there's really not a strong need to jump from version 4 to version 6 just yet. I was curious about, when the official date was for switching from, I was asking myself, when are we going to switch from version 4 to version 6 officially? And then I did some looking and realized we already had our launch day back in 2012. The reason I missed it is because I was in the middle of writing my dissertation and finishing up my doctoral degree at the University of North Carolina at Greensboro, and just completely missed this. But if you look at the wikis for World IPv6 launch day, you'll see there's a logo, there were t-shirts, you can see all the companies that were involved, Google, Microsoft, Yahoo, Verizon, all the big ISPs were there to kind of do a test and make sure everything was working. And it is working. Now it's just a business decision for every other customer company that rides on those networks to switch over as they can. Okay, a little vocabulary review here. When we first started talking about IP addresses, I said that in the abstract there are three parts to every IP address, and we call that the network part, the subnet part, and the host part, and that the subnet mask told you how many bits you could use for the network and subnet, and how many bits you could use for the host. Now with version 6, they renamed all this stuff, so the network part is now called a routing prefix, okay? The subnet part is called a subnet ID, easy enough. The host part is called an interface ID in version 6, but it serves the same purpose. So with version 4, we've got a 32-bit address. We go up to a 128-bit address with version 6. So notice that out of 128 bits, you can split it in half and half. So 64 bits is always going to be assigned to the host. What's interesting is the host, because this is being written out in hexadecimal, we can actually use, if only we had a unique address in hexadecimal that we could assign to every device. We already have that. It's called a MAC address, right? So we can actually use the 48-bit MAC address, and yes, we're wasting a couple of bits, but it fits in the 64-bit part of the address to serve as the interface ID. Which leaves 64 bits for the network and subnet part. So rather than needing a subnet mask, we just know that this is going to total to 64 bits. Please keep in mind I'm being very superficial on the differences between version 4 and version 6. I do encourage you to do some more reading on your own on version 6, because this is the world that you are going to be inheriting. Tech Republic is a good source for kind of more technical articles, and that's one that you should check from time to time, I would say. Well, how does DHCP work in version 6? Well, there is a V6 of DHCP that works pretty much exactly the same way that it does in version 4. PC boots up, sends out a broadcast, and gets but instead of a 32-bit address, it gets a 128-bit hexadecimal address from the DHCP server. The server has to be running DHCP server service version 6 for this to work, of course. But then we've got something new, something freaky, called stateless auto configuration. So you don't need a server anymore to assign you a valid IP address. Instead, your machine can configure itself and give itself a valid IP address. Let's take a look. And this is a possible test question, right? That stateless auto configuration does not need a DHCP server anymore. So this is completely alien to what I'd learned when I was doing networking. This is new and crazy. Stateless auto configuration, we can't get too deep into this, and I'm oversimplifying the process. If you want to think of it in terms of two steps where we have to figure out 64 bits and 64 bits out of our 128 bits. 64 of those bits are going to be the link local address. There's a new protocol in version 6 called the Neighbor Discovery Protocol that will kind of send out a broadcast to make sure it's not using a duplicate address. And then if it needs to send a message out to the wide area network, through the router, of course it needs to append the router prefix and subnet ID, what we used to call the network and subnet portion of the IP address based on the subnet mask. It just appends that and those 64 bits to the other 64 bits based on the MAC address to come up with this unique hexadecimal version 6 IP address. But it does this without talking to a server. Weird. So if DHCP is weird in version 6, how about DNS? Is that weird? Well, it's not as weird because it's just a new version of the same thing. There is a version 6 of DNS, but because the addresses are 4 times as long, we call them something different. In DNS, it's called an A record. I'm not sure if that stands for alias record. I think that's what it refers to, but it's just called an A record. Each row in the table is an A record. So because they're 4 times as long, it's an A record. And if that sounds dumb, wait for it. Here's what we call it: a quad A record. Isn't that cool? Because IT people are cool. That's what we call it. Quad A. And how about our ARP protocol? Is that in version 6? No. We lose ARP. There's no need for ARP. There's no need to do this MAC address to IP address translation because the ICMP Neighbor Discovery Protocol, it's a new protocol in version 6, takes care of that functionality. So we don't need ARP anymore. ARP go bye-bye. Bye-bye. Well, we have to wrap up TCP/IP now, and so I wanted to leave you with some advice based on my own experience troubleshooting networks. Also, just that these are good interview answers when somebody's asking you. So, for example, you listed TCP/IP on your resume. Can you give me an example of how you troubleshoot a TCP/IP problem? There are a couple of great answers to this. One is that, I logically go through the layers and, rule out if it's a layer 1 cabling problem, if it's a layer 2 switching problem, if it's a layer 3 routing problem, layer 4 port problem, layer 5 application problem, and so on. They're looking for some kind of answer that says you're narrowing down the possibilities. Another way to do problem solving is with a network diagram, especially for a more complex network. This is really going to help to figure out where the breakdown in communication is happening. It's also very helpful to think in terms of protocols. If something's not working, is there another protocol in the TCP/IP stack that is working? So if NAT's not working, is TCP/IP installed correctly? Can you ping that loopback address, which is 127.0.0.1? If you can get an IP address and ping IP addresses, but you can't ping a name, you're narrowing it down to a DNS protocol issue, and that would kind of take you down a different path for troubleshooting. Narrowing down the possibilities is the key, and it's only when you have a good map of the network that you can do that. So pinging from, can I ping from here to my network card to the default gateway, which is the next hop over, to the router on the other side. Pinging each step helps you figure out where the problem is, and particularly if you're troubleshooting a VPN issue like Jim Musselman is going to talk about next time. And certainly, so it's not silly to answer an interview question saying, well, I'd use a heck of a lot of ping commands to figure it out, because that's just the way it is. Also, just having a laptop. You've got to have a laptop if you're a network engineer, because you need to be able to test things out by kind of patching into different parts of the network. So if you're in the data center, I can plug into this switch to see what's going on here. I can plug into the switch up here to see what's going on there. I can plug in inside the firewall or plug into a switch outside the firewall to test pinging from different points in the network. If you if you see what I'm trying to say. Again, if I could whiteboard this out for you, it'd be a little easier. So my final wisdom for you is, what I've learned about troubleshooting TCP/IP. When in doubt, reboot. WIDR. That's not a real acronym. I just made it up. When in doubt, reboot. It works for PCs. It works for firewalls. It works for routers. Works for switches. Works for access points. It works for a whole host of network boxes that if you're stuck and you're not sure what to do, you're trying to just reboot the damn thing. Usually it'll start working again. And when all else fails, of course, read the fine manual, because there are a lot of good answers to, how do you do troubleshooting. I know what the wrong answer is to this question. The wrong answer is, well, I would just ask somebody who knows what they're doing. I would ask a senior person. I would ask somebody else. That's not what the hiring manager wants to hear, that you're just going to go bug somebody else. They want to know that your Google foo is strong. You're going to read a PDF. You're going to read the manual. You're going to do some research on your own. You're going to Google some forums. You're going to go to the manufacturer's website. You're going to figure it out on your own. That's the right answer to the question. So with that, there's nothing more for me to say besides, oh yeah, aloha! Coconutty.